Alright, this begins 7.1. It goes over confidence intervals for the population mean when you know the standard deviation, which is a little bit weird because why would you know the standard deviation if you don't know the mean? But these situations do arise, and we'll look later if we don't know the standard deviation. There's two different type of estimates that you can get. One is a point estimate, which is just one number. You can't really know how confident you are in a point estimate because the chances that it's that exact number is really low. I mean, obviously, we're going to find the number that's the most likely number to find, which of course would be the sample mean, as explained right here. But at the same time, the chance that it's actually the same exact value is pretty low. Next, we're also going to be thinking about interval estimates, which means that we're going to be looking at a range of numbers. So down here in this paragraph, it basically explains that you could find the fact that the population mean is between 21.9 or 20 and 22.7. So this gives us an interval, and that way we can actually figure out that, well, if it's all these different values, what percentage of a chance is it accurate? And explained in the next paragraph, you could find out that it's 95% accurate. You could find out that it's 99% accurate. And obviously we want to be as accurate as we can, but we also don't want the interval to be so large that it doesn't really tell us anything. But basically it's going to be getting into confidence level of each confidence interval, which should make sense. To really get us into this section, one thing we have to understand is z sub alpha over 2. It's in a lot of formulas, and you might look at it and just say, oh, what the heck is z sub alpha over 2? That is basically saying that if you want to be 95% accurate, you're going to have to find the middle 95% of the standard deviation curve. So if you think about the standard deviation curve, we're going to have the middle 95%. These are like questions that we had before, which means that over here we're going to have 2.5%, which in the standard deviation chart, that would be 0.025. Or you could have the 2.5% up here, which would be 0.975. And basically, these numbers are going to end up being plus or minus the same value. And this value is plus or minus 1.96. The book usually just looks for you to find the positive value because you know what the negative value is going to be. But the z-score would be equal to plus or minus 1.96 if you want to be 95% confident. Now there's a formula for all this, and it's in the book. It's explained in the book and explained in the reading. I'm going to explain it more later, but just note the fact that you have a minus here and a plus here, because of course those numbers can be plus or minus the z value, and you have standard deviation and n. So I've seen this before as well as the sample mean plus or minus that z sub alpha over 2, and then you're multiplying by the standard deviation divided by root n. Now, other things that we're going to be looking in the lesson involve margin of error, which is called the maximum error of the estimate. It represents the maximum likely difference of a specific confidence interval. So that difference, of course, could be a range of values depending on your mean and your standard deviation. We're also going to be looking at examples such as 7.1 and 7.2 in other videos, and those basically just explain the fact that you have these z values, you have the sample mean, you have the population standard deviation, and you have n. Do note n, of course, if you're creating a study, could be any amount of different values. Obviously 50 is not going to be as accurate if you had chosen n equals like 200 or 2,000 or 2 million. And the higher the n gets, and that's the reason why it's in the denominator up there, the more confidence you can be and the smaller your interval can be. Here's a good graph explaining if alpha, so alpha is your error. If you want error equal to 0.02%, which means that you're 98% sure, or sorry, just 0.202, that means the alpha over 2 is 0.01, and then you have this 0.01 on both sides of the standard deviation curve. And for this value, you would look for 0.995, or 0.01. The book again likes to show that you're looking for 0.99. You just note as well that 0.9901 is actually closer to the value, but here we're going to always, round up in general, just so that we're 100% sure that we're getting the limits. If it was closer and it was 0.9899, which is actually about the same, we're still going to pick the higher value because we want to spread our range to actually fit our accuracy for sure. Later on, as I mentioned before, we are going to figure out how big our sample size should be. It's got a little bit to it at least, but obviously the bigger the sample size can be, the more accurate it will be, but of course sometimes we can't get huge sample sizes. If we look on this slide, this is the formula for figuring out how big the sample size should be. If we know the error we want, we know z sub alpha over 2, and we know our population standard deviation. And of course we'll look at examples of this as well. Well, that's it for the section review. If you're a little confused on any of the questions, obviously rewind or check the reading. And if you want help with anything that you're actually calculating, choose the videos that are dedicated to that.